Hello guys, this is Bhavin Kumar Patel. I am doing in the second task of GRIP April 2021, which is of basically predicting using unsupervised clustering model from machine learning. It is basically from iris dataset, and we have to predict the optimum number of clusters and represent it visually. So from the given iris dataset, we have to predict the optimum number of clusters and present it visually. So first of all, we are going to importing a libraries, and the libraries are we are importing in this visualization part is NumPy, Pandas, matplotlib.pyplot as PLT. This is the main library, and the we are using the style in the graphical representation. So I have used the matplotlib import style. Then some of the graphs are using Seaborn's library, so that's why I have imported also. Basically we are using the k-means clustering model. So here sklearn.cluster having the k-means clustering algorithm, that's why we have imported the clustering cluster and k-means. So now we are going to import the first uh, iris dataset. So iris dataset is basically I have imported from uh, task the task which is provided from the grid. So on the online link, and then download it to my local drive, and now I am importing it from my local drive. uh, Let me import in and showing the results of the iris. So basically there are 6 columns, that is first is id, second is sepal length, sepal width, petal length, petal width, and the space size. Let's displaying the detailed information of the dataset with using info function. So by using this info function, we can say that there is not a single null value or missing values from here, because we can see that 150 full of the all of the data are available here which are not null. So we can come to the uh, result that after looking at the above information of iris dataset, we can say that there are no null or missing values has been there found. So now let's look at the description of data, which basically combines the count, median, and mean, standard deviation, the first quartile, second quartile, and third quartile. Then after let's just look at the unique values of data. So ID is generally having 150 members of 150 unique data, unique numbers with ID. So all of the IDs are in unique general way. In sepal length there are 35 unique members. In sepal width there is 23. In petal length 43, petal width 22, and space size basically 3. That is, we can say iris setosa, verticolor, and virginica, as we can say versicolor and virginica. So let's go to the columns. Let me display the columns. So columns are basically this, but I just need this column because I just want to find each and every column's unique value. So here I can find the unique value by using unique function, by calling data and sepal with particular feature name dot unique function, which is used to find the unique values. Then same like petal width. So petal width is displaying unique values for petal width column. So now let's moving to the visualizing part of this model. So let's first create a scatter diagram of sepal width and petal width, which is having the orange color, and I have placed the sepal width on the X label and petal width on the Y label. And let me show this one. So this is the visualization. of sepal width and petal width. So let's go for the sepal length unique values, petal length unique value, and the scatter diagram of sepal length and petal length. Yes. Now let me go to the separate histograms for each and every features. So I have creating and displaying us this histogram of sepal length. Yes. Then same like in sepal width, petal length, and petal width. So now let me separate the x-axis, x that is the feature, x features from the whole data set. I have taken the index location of the index location of feature and particularly combine the column 1, 2, 3 and 4. That is, let me yes, let me display it first. So as per the I can see, and you can also see as per I let me data dot head function, let me execute it. So basically sepal length is at the column 0, sepal width at the column 1, petal length at column 2 and petal width at column 3. That's why I have taken here 0, 1, 2 and 3, because I don't require any kind of the IDs, and the space size is specifically for the visualization purpose and the clustering purpose. I just want to cluster these 4 columns. That's why I have taken this 0, 1, 2 and 3 values. So let's move ahead. Now we are going to, if we want to create a cluster, then we just have to uh, select the elbow method, and by using the elbow method we can go for clustering. That's why let's go for creating the elbow method, and elbow method displays yes, there is elbow method means the band means the separate cluster. This is the one, I can say this is the one cluster like here. Now it is elbowing here, that's why this to this much, this should be the second cluster. From this to this should be the third cluster. So I can say that 1, 2 and 3, there is the 3 clusters, the possibility of majority of 3 clusters. So I have creating the cluster and predicting. So k means, using k means I am using n underscore cluster equal to 3 as per our elbow method, and the random state, this is the by default 42, or we can say 0, I can take 0 also. So now the prediction, predict, y predict is equal to k means not fit predict. So fit predict x contains the value of these 4 columns, the I index location of these 4 columns, that is sepal length, sepal width, petal length and petal width. So let's take and creating and cluster and predicting the x. So we, after creating a cluster and predicting the x, we can say that if I display the y predict here, then y predict and the clusters are behaving like this. This is the first cluster, this is the second cluster, and this is the third cluster. So by displaying now this y predict on the visualization part, because this is somehow very hard to understand that how this is represented. So we are using the we are using the easy way to understand this data by using scatter plot. So let me plot this one. So here it is. So this is a versicolor, and this is the centroid of this versicolor cluster. This is for Virginica, and this is the centroid for Virginica cluster, and this is for Setosa, and this is the centroid for Setosa cluster. So there are basically 3 clusters that we have created, and they all are having their own centroid points, and these centroid points decides that which node is coming under which cluster. That's why we are using centroid. That's all, friends. Thank you so much.